Hi, in the project you'll see this JavaScript demonstration provided by statkey. It's a website that I just linked into the project, and it's trying to demonstrate the following problem, which they provide through a PowerPoint. Students are given words to memorize and randomly assigned to either take a 90-minute nap or stay awake and take a caffeine pill. 2.5 hours later, students are tested on their memory or recall ability. So mean number of words is mu_s if the student sleeps, and mu_c is if the student consumes caffeine. And is it possible that the sample average for sleeping is minus the sample average for caffeine is 3, so this is bigger than that. Okay, so how if you were to do a significance test, are the two equal versus they're not equal, what would you get? Well, they want to illustrate this with a permutation test. So here's the data. These are the students that were observed having caffeine, and it's in a dot plot, so there's some replication. Not replication, but people with the same scores. Here's the sample average of 12. Here's those that slept. It seems to be a smaller sample. Again, there's some repeated numbers there. Average was 15.25, and the difference was 3. The question is, how unusual is that? So if we look at the null hypothesis, we see that we could just have no effect, meaning that it didn't really matter. This is just how much these students remembered. It didn't have a difference whether they had sleep or caffeine. So if we had reshuffled what we had done to these students, their response wouldn't have mattered. So that's exactly what this demonstration does. It reshuffles. So if we generate one sample, we see that it has reshuffled the data. They look kind of similar, but if you look carefully, they are totally different. Well, not totally different. And this particular difference provided one of 2.83 as opposed to the original of 3. It's plotted here with a little dot. Okay, so let's do another one and see that we get a second dot. It shifts over to here. It's -2. So then what happened instead of, it's 12.75 for the sleepers and 14.75 for the caffeine people. So what we see is when we reshuffle, we get very different scores. Our goal is to understand how unusual was it that we got this 3 given that the null hypothesis of no effect is true. Okay, so we can get that by doing a bigger simulation. We want to look at a right tail test. Okay, so let's get going. If we generate 100 samples, we get a bigger sample. We see that 3 becomes fairly unusual. It's only 3 values out of this 100, and I guess there's probably 102 there. We generate another 100. We get 5 values now of the 200, and we can generate 1,000 to get a bigger idea of the distribution. It takes a little bit of time, but there we go. We see that it's relatively unusual. And then if you play around with the demo, you can actually get the p-value because it helps you. The numbers there, you can't quite see it. Anyway, that's the idea of simulating an approximate p-value for a permutation test. Instead of computing the exact distribution, you do simulation many times doing the same thing, and all we do is shuffle what we call sleep and caffeine, and then compute these two means and take the difference and plot it on this graph, and then look for how unusual was our observed value compared to all the values that we generate.